Hi everyone, and today I would like to share with you the lazy approach how to deal with the quick sort. It's easier than the bubble sort, especially if you didn't face it before. I guess that you will be shocked that the sorting algorithm could be like really trivial, and especially for the you know some kind of understanding and reminding point of view. uh, that's the joke, but it's possible to do the quick sort without any partition finding and other related things. And so let's try to approach it on the array which I described here in our escalade row. And so for approaching the quick sort, we should do, like, I would say, three steps, three main steps. First one, in case if our array length less or equal than 1, we should return result, return array. Second case, so find the pivot, find let's call it the middle number in the array. Like, create 3 subarrays. Like, first with numbers less than middle. Second, equal to middle. And third, bigger than middle. Join them and return the result. Yeah, sorry, not 3 but 4 steps. Yeah, so return the result with recursion. I would say that some sort function, sort for less plus middle without any changes, because of it's equal, that's just the numbers which are equal to 1 or any other element which we add there as a middle. Yeah, middle and sort bigger. 4 steps, like really easy, just to remind that and use in any scenario. So, and easy to understand. Let's try to approach it step by step. So for this array, like the size of this array is equal to 7, and let's divide the 7 by 2. We are trying to find the middle, so it's like 18. So if that's the case, let's do the first iteration. For the first iteration, our middle, let's call it pivot, equal to 18, third element, because of, so we divided 7 by 7 by 2, we will have 3. So, and if that's the case, 18 is the third element there. Okay, so let's think, like, less. will be what? So what is the numbers which are less than 18? 2, 1, 5, 7, 3, 4. So our middle, yeah, equal to just 18. And there is no bigger. That's all. For now, we should use the recursion. Let's see. Yeah, so we use the recursion here and here. So for the second case, we are going to do like the same for this subarray less. Yeah. What is the middle in this situation? So the size is 5. Yeah, this is the 5. Divide by 2, we will have 2. Then our middle is like our pivot is equal to what? To 5. Yeah, this is 5. So, and if that's the case, our less will be what? Like 2, 1, 3, 3, 4. And so middle will be 5, mid will be 5, and the bigger will be empty. We haven't bigger, still haven't. So if that's the case, we are joining, yeah? So this less plus mid, and that's all. So still didn't sort, like 3. Step 3, so we have this subarray 2, 1, 3, 4, divide by 2, so that means that we will have the pivot equal to what? To 3. Yeah, 3. So the less will be probably 2 and 1. And our mid will be 3 because of only one element equal to 3. And the bigger equal to 4. Yeah, that's it. Okay. And we still have just the 2 elements over there. So we should do the 4 iteration. Like we have the 1, 2. So for pivot, we divide by 2 and we have 1 as a pivot. So from the less side, we have an element. For the mid, we have 1. And for the bigger, we have 2. And that's it. So we didn't have the recursion there. And for the recursion stack, still we are getting here. So we are joining them. We will join this part. So we should join it like, you know, when we call for these items, join. Yeah, so join will be like 1, 2, like 1, 2, plus 3, plus what? Plus 4. Like 1, 2, 3, 4. So I'm wondering if it looks correct. Yeah, probably that's the correct approach for this part. So, and for this one, we will do the same, like this 1, 2, 3, 4. like and plus 5. So let me copy that, like join 1 2 3 4 plus 5. Then we will have 1 2 3 4 5. Okay, so looks fine. And here we will add other elements, so like we will add more, and as a final result, so you may approach it on your side, but as a final result you will have the sorted array. So like you will have 1 2 3 4 5 7 18. Try to play with that on your end, and so probably that could be the good exercise to understand how is it working under the hood. I believe that it's kind of, kind of great example how to deal with that. And let's try to implement it, because of probably it's simple. Yeah. Okay, so first of all we have the recursion call here, and so let's start from the, as a best practice, let's write the approach how we leave the recursion. So like if len of our nums, yeah, this is called nums here in the signature, less or equal than 1, what we should do, we should return nums. Okay, that's fine. We left the recursion. So let's find our pivot. Pivot will be equal to the nums len, the same function, yeah, from our nums, divide by 2. Cool. Step 3, our less array. So we are running, let's call it x as a variable. So we are running x in the nums, and so we are populating there all elements which are less than what? Then our pivot. Next step, middle, will be the same. Let me copy that. But all elements which are equal to pivot. And the last one, all elements which are bigger than pivot. Let me change the name of the variable, like bigger. Okay, that's it. And what we should return there, as we discussed before, we are going to return self sort an array we pass here less plus, thanks God we have the like overloading of the operators in Python, because of in Java if I will use Java, then I should create some function for doing that. Self, like the same sort array for the bigger part. For a bigger part, one more time. Yeah. So what we will have as a next step, I would say that we will have the passed test cases. Let's check. Yeah. So, but I would say that in case if we have these large numbers, yeah, that's true. If we have these large numbers of the elements there, we probably will have the some time limit exception from the testing system. But that's fine. I would say that like I'm voting that it will pass at least 5 to 10 cases. Let's try. Let's wait. Let's wait. Oh, oh, unbelievable, guys. It's passed 13 test cases from 21. So that's the easiest approach how to like remind the quick sort. And currently your goal is to check how to deal with that without copying the data and without spending a lot of memory here. So, and what about the time complexity? So time complexity for this solution will be like n multiply log n, uh, standard for the quicksort, but for memory it will be like bad. Yeah, so because of the recursion stack, because of the calling each time a new arrays. So I won't currently calculate all of these things. So this is for the time, and this is for mem. Uh, so that's all. As I said before, that's much easier than our like bubble sort, or in like any other types of the sorting algorithms, and it's really simple. Try to practice. Try to understand how to find the partition correctly and how to swap the elements there. So it's just an additional exercise, but the main idea is really simple, like we describe it here. Just 5-6 lines of the code, and a certain algorithm is there. If you would like to hear about that, I might create another video about the like more complex approach for the quicksort. Thank you for your attention and have a nice day. See you. Bye.